Good morning everyone. Myself Dr. N. Pratyusha, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today I am discussing about Fourier transforms part 2. It's under numerical methods and integral transforms. So this is the overview of today's session. First we will discuss about infinite Fourier transforms and some examples about the Fourier transforms. So this is the formula for infinite Fourier transform and its inverse. So the Fourier transform of a function f of x is given by f of x equal to f of p integral minus infinity to infinity f of x e power ipx dx. So the inverse Fourier transform of function is denoted as f of p. So f of p is given by f of x equal to 2 by pi integral 0 to infinity f of p e power minus ipx dp. Here just we are inversing this formula, we will get the inverse Fourier transform. Okay. So here the basic first example was find the Fourier transform. If they didn't mention finite means it's infinite Fourier transform. For finite Fourier transform, they will given find the finite Fourier transform. It's not given means it's infinite. So find the Fourier transform of f of x is defined by f of x equal to 1 minus x square if mod x is less than or equal to 1, 0 if mod x is greater than 1. Hence evaluate or hence deduce integral 0 to infinity x cos x minus sin x by x cube cos x by 2 dx. Here they are given hence evaluate or hence deduction means we have to apply inverse also. They particularly they didn't ask for inverse. Deduction they given means we have to apply the inverse. Okay. First we will write the Fourier infinite transform formula. So f of x equal to f of p equal to integral minus infinity to infinity f of x e power ipx dx. So here f of x is the discontinuity function. So we are splitting the integration, we will get, so integral minus infinity to minus 1 f of x e power ipx dx, because here 1 is given, right? So that's why we are splitting the integral as minus infinity to minus 1, minus 1 to 1 and 1 to infinity. So here for f of x minus infinity to 1. So this is 0, right? So 0 into e power ipx dx. Mod x less than or equal to 1 means minus 1 to 1 limits, right? So that's why in minus 1 to 1 limits I am substituting f of x as 1 minus x square and into e power ipx dx plus 1 to infinity. So the greater than 1 means 0, right? So 0 into e power ipx. This term is 0, this term is 0. Only left term was integral minus 1 to 1, 1 minus x square e power ipx dx. This is x term, this is also x term. So we will apply integral uv dx. So what is the formula for integration? So u into integral v dx minus integral d by dx of u integral v dx whole dx. This is the formula, right? So here u is 1 minus x square and v is e power ipx. So we will substitute in the formula, we will get u term is this, right? 1 minus x square. So integral v is what? E power ipx dx, right? So integral e power x dx is e power x, right? So e power ipx, but in the place of ip is there, right? So we will write in the denominator. So we get e power ipx by ip. So in the limit minus 1 to 1. Next minus integral minus 1 to 1 d by dx of 1 minus x square. U is 1 minus x square, right? So 1 derivative is 0, x square derivative is minus 2x. This is minus 2x. So integral e power, in the place of we substitute e power ipx dx. So 1 minus x square divided by ip, e power ipx, in between the limits minus 1 to 1, 2 minus into minus plus, 2 is constant, integral minus 1 to 1, x term is written here, and integral ipx derivative integration is e power ipx by ip into dx. Okay. Next, again we get the uv. Here u is x and v is e power ipx. Because 1 by ip is constant, we can write in the outside. So we will get, if you substitute 1 comma minus 1 in this function, if you substitute 1 minus 1 square by ip, e power ip into 1. 1 minus 1 is 0, right? When you apply upper limit, we get 0. If you apply second limit, means minus 1. So minus 1 whole square also 1, right? 1 minus 1 is 0. So if you substitute both limits in this function, we get 0. So that's only here written. 1 by ip, 0 minus 0, plus 2 by ip. Because 2 is constant, ip is also constant, we have written in the outside. So integral minus 1 to 1, x into e power ipx. Here x is u and e power ipx is v. So again we will apply uv formula for integration. So x into e power ipx integration was e power ipx by ip, minus x differentiation is 1 and e power ipx by ipx integration was e power ipx by ip. So we will get 2 by ip, x into e power ipx by ip, this term, minus 1 by ip is, you get e power ipx by ip, right? So 1 by ip is constant, we will write outside. So 1 by ip integral e power ipx dx. This is right. So 1 by ip integral e power ipx dx integration was e power ipx by ip. So when we will multiply, we get e power ipx by ip whole square. This term was this integration. Next we will substitute upper limit and lower limit in the function. We get e power ip in the place of x 1, right? So 1 by ip. So next minus 1 by ip square. So sorry, 1 by ip square. Here we will put minus 1. So ip into minus 1. So minus ip. ip into minus 1, we get minus ip. So we get e power ip plus e power ip. So I square value is minus 1, right? So here minus is there. So minus into minus plus, I square is minus 1. So minus into minus plus p square. So minus e power minus ip by ip, minus here also, here minus into minus plus, and next I square value is minus. So plus into minus, minus e power minus ip by p square. So we will common out the terms, we will get. So here 1 by ip I will common out, I will get e power ip minus e power minus ip. Here I will accommodate 1 by p square, I will get e power ip minus e power minus ip. So in the place of e power ip minus e power minus ip, so 2 cos p I am written, because we know that e power ax minus e power minus ax by 2 value was cos ax, right? So here also in the place of e power ix minus e power ix, I substitute 2i sin p. So I will get final answer as 2 into 2 common out I can take. So 2 into 2 4 minus p cube also I will common out, p minus p into means LCM. So minus p into cos p plus sin p by p cube. So I will get final answer as f of x equal to 4 by p cube minus p cos p minus sin p. So this is the Fourier transform. But in the problem they given detection, hence evaluate they given, right? So we have to apply inverse Fourier transform also. By the inverse Fourier transform formula, we have f of x equal to 1 by 2 pi minus infinity to infinity f of p e power minus ipx dp. So what we get f of p? 4 by p cube minus p cos p minus sin p is right. So I am substituting f of p in the formula. I will get for 1 by 2 pi integral minus infinity to infinity 4 by p cube minus p cos p plus sin p e power minus ipx dp equal to f of x. What is f of x in the problem? 1 minus x square when x is less than 1, right? So that's I am taking, because another is 0. So 1 minus x square if mod x is less than or equal to 1, 0 if mod x is greater than 1. For detection, I am substituting x equal to 1 in the result. So minus 1 by 2 pi 4 minus integral minus infinity to infinity 4 by p cube p cos p minus sin p. Here minus I am common outing, that's why I am getting p cos p minus sin p. In the place of x 1 by 2 is right, e power minus ipx, right? In the place of x I am substituting 1 by 2. So I will get e power minus ip into 1 by 2. So that is e power minus ip by 2. This term into dp. So f of x is 1 minus x square, right? So in the place of x I am substituting 1 by 2. So 1 minus 1 by 2 whole square. So 1 minus 1 by 4, that is 3 by 4. This result. So here 1 by 2 pi is constant. So I am taking it another side, means right hand side. We will get 3 by 4 into, so 2 pi. So I will get as 3 pi by 8 and 4 is also taken out. So I will get 2 ones, 2 twos, 3 pi by 8. Here minus. So just I am taking out 4 and 1 by 2 pi into the right hand side. I will get in right hand side minus 3 pi by 8. So now we have integral minus infinity to infinity 1 by p cube p cos p minus sin p. This is in the form of e power minus IAX, right? What is the notation of e power minus IAX? Cos AX minus I sin AX. Here in the place of x, what is there? P by 2, right? So I am substituting here. So e power minus AX equal to cos AX minus I sin AX. So cos AX minus I sin AX. So in the place of x, we are substituting p by 2. So we will get cos p by 2 minus I sin p by 2 dp. By equating real parts of the both sides. only we are equating the real parts, means imaginary part will be eliminating. So we will get integral minus infinity to infinity 1 by p cube p cos p minus sin p. Only real term is here cos p by 2, right? So cos p by 2 dp equal to, here no imaginary term is there. So minus 3 pi by 8. So here 2 minus infinity to infinity, I am writing 0 to infinity because this term was even integral. So that's why you are writing 2 into integral 0 to infinity p cos p minus sin p by p cube cos p by 2 dp equal to 3 minus 3 pi by 8. So here 2 is constant. So I am writing it in the right side. So we get minus 3 pi by 8 into 1 by 2. So the result was minus 3 pi by 16. First, in the problem, we are integrating by parts, and next we will get the f of x, that means Fourier transform. Here in the problem, they given the hence evaluate term, that means we have to apply the inverse Fourier transform also. The inverse Fourier transform formula was f of x equal to 1 by 2 pi integral minus infinity to infinity f of p e power minus ipx dx. So already we got f of p value at f of x means f of p, right? So I am substituting f of p in the formula and f of x what the problem is given. So next I am taking x equal to 1 by 2 and that will be substitute in the formula. I will get, so minus 1 by 2 pi integral minus infinity to infinity 4 by p cube p cos p minus sin p e power minus ip by 2 dp. This is in the form of e power minus ix. So I am substituting x in the p by 2. Here also in the place of ax I am substituting p by 2. Next I am equating only real parts. So I get integral minus infinity to infinity 1 by p cube p cos p minus sin p cos p by 2 dp equal to minus 3 pi by 8. The integral was even, so I am writing integral 0 to infinity 2 into p cos p minus sin p by p cube cos p by 2 dp equal to minus 3 pi by 8. Here 2 is constant, so that's why I am taking it in the right hand side. So I will get minus 3 pi by 16. This is the result of this problem. So if deduction is not given, so we need not to find the inverse. If they given extra evaluate or deduction, we have to find the inverse also. Okay. So today's session we have discussed about the infinite Fourier transform formula and the formula based example. Okay. In today's session we are discussed about infinite Fourier transform and example based on infinite Fourier transform. In next session we will discuss about the infinite Fourier sine and cosine transform. Infinite Fourier sine and cosine transform. In the problem they mentioned finite means then only we will find the finite Fourier transform. If they didn't give means we will find the infinite Fourier transform. Okay. Thank you.